Okay, so next up we have Bernard Grabowski, who will be talking to us, excuse me, about Whiz, a half-size machine, and also giving us a little demonstration of some work done in Visual Basic, which is the up-and-coming new programming language that I recommend you all get behind immediately. Thank you.
Thank you very much for that. It's kind words. Okay, Whiz is a dedicated line follower, and I've been working on various versions of it for a few years, and now I've got it to the stage where I think it's pretty competitive. And so I thought I'd let you know what I do. Promise I won't get too technical, so I'll just run through the slides, if it'll let me. So there's what it looks like when it's set up for normal competition. That's what it looks like underneath. You'll notice I don't use a professionally made PCB. I would do, except I keep making changes. It's hardly worth it. When I get a mouse that's I consider to be perfection, I probably will. You'll notice there that there's a bit of dubious extra wiring put in to swap things over. Motors went backwards when I tried it the first time. And last time I competed with this mouse, I found that it wouldn't work because there was ambient light getting in under the front, so I had to make a little hat for it, and did that on a 3D printer, and it just clicks into place should the course be put near the window. So a basic line follower has to do few things. Has to follow the white line, start and stop where it should, do something with crossovers, basically ignore them if it's a basic mouse, and then stop in the start-finish area. But a competitive rules-compliant mouse needs to do a bit of calibration, use a survey run to map the course, and then take that data so that it can run on its second and third runs much faster, and then be capable of sending data when you're testing. You need to be able to see if the mouse is getting all the side markers, so you need to have something like Bluetooth and TerraTerm, something like that, so you can save and display the data. Sensors, as Duncan has quite recently said, are very important, but I use a simple photo interrupter, QRE1113, and I use quite a few of them, and motors, everybody and his dog uses these, brass gearbox motors. I use the magnetic encoder, which a lot of you use for your mice as well. Never found anything better. Maybe we'll hear in a later talk that there is something better out there. I did try the Pololu wheels, which are a great match with those gear motors, but I found them susceptible to slip, although I do think that the tread makes the mouse a little bit less vulnerable to a dusty or a dirty track. I don't know the exact science of it, but I decided at the end I wanted lower profile and wider and more grippy tyres. And some time ago, Derek put me onto these Mini Z tyres, which are 20 Shore slicks. They've got brilliant grip, but they're great dust gatherers. You want me to run before you when you run your mouse, because I'll pick up all the dust off the track. So I use multiple line sensors, 7. You may well ask, why do you need 7? You can get away with 2. Well, I haven't got a reason. The first prototype that I made had 7 and had them in a sort of radius centered on the center of rotation, which seemed like a good idea at the time. And the side marker sensors were quite near the front on there. Now my latest version has got the sensors in a straight line. I'll tell you why later. And the side markers are way down here. So there's the visor statistics. It's weighing 116 grams with battery included, 42 millimeters tall. It's got Pete will love this. It's got a PIC microcontroller, and I program it in Proton Basic, which has now been taken over by the person that wrote Proton Basic as a private concern. You can get it for 40 quid. So if you like Basic, now's the time to buy it. And I control the motors with a TCA 0372 power op amp circuit that Duncan designed, and he's now working on an improved version that uses MOSFETs? Discrete components, but it means we don't need the TCA 0372, which you can't get anymore. So the marker sensor position, you can put the marker sensor in line with the main sensors anywhere down there up to about the axle. And the marker sensors are going to be 35 millimeters from the center of the mouse, which is the center of the line. But you have to think about it when you position these sensors. A lot of these things these dependencies are interrelated. If you get, our course builder is a real bastard, and if you get these conditions where you have a long, narrow radius, 75 millimeter radius turn, then you get a marker there. Your mouse gets into this sort of position. It's only approximate, but you can miss the marker quite easily if you've got a sensor right up here. But as you go down here, you're more likely to hit it. And I thought that, I'll go the whole hog. I'll put it on the axle line. What could go wrong? And it does have an effect on motor position because being on the axle line, of course, that's where the wheels normally go. So these marker sensors mean you've got to push the wheels the other side. They can go on the inside on a full-size follower, but that's an obsolete competition now. So the wheels are going on the outside, and the motors are now 20 millimeters apart. On the plus side, the magnets won't interfere with each other, but you don't know whether this increased track width is going to be a positive or negative effect on the actual running of the mouse. It may possibly have an advantage. There might be some relationship between the dimension from there to there and the dimension from there to there. Who knows? So it's a black art. Now, crossovers. One of the most important things that a competitive mouse has to do is to deal with crossovers, either to acknowledge them or to ignore them, but it's got to handle them. So last year's course, which is tomorrow's course, has got 6 crossovers. You have to negotiate a crossover each way, and there's 3 of them. So you've got to be able to reliably do something about crossovers. So it mustn't make a left or right turn. It's got to detect it as it's not got to detect it as a left or right side marker for curvature or start-stop. And your following algorithm must not joggle or somehow be disturbed by the presence of the crossover. And that's one of the reasons for the 7 sensors. So as the mouse approaches a crossover, I know I've talked about this before, but some of you might not know this weighted average method of reading the sensors. You basically take the sum of all the readings of the sensors, and you divide that into the value of each sensor times an increasing value. So if it's 500, it's 0 times the first sensor, 500 times the second sensor, 1,000 times the third sensor, and so forth. And that gives you a reading which increases from a small number to a big number, and then you subtract half of it and you get to the middle, and either side of that you've got minus on one side, plus on the other, and it allows you to get a positional error. And the beauty of using that method is you've already read all the sensors and added them together. So what this mouse is going to do, it's going to read all 7 sensors, and it's going to take a threshold value, and if it exceeds that threshold value, in other words all those sensors are on the line, or at least most of them, then the mouse will know that it's a crossover that's approaching and not a side marker. So at that point there, the mouse has reached the crossover, and most or all of those sensors are going to send a very high reading. And what the program does at that point there is to say, stop looking for markers for a while. So until you get to that point there, you're clear of the crossover now, so you can start looking again. So there's no detecting of trailing edges or anything like that. You find the leading edge, and then you add on to the odometry value at that point a certain distance, which is the distance from there to there, plus 10, 20 millimeters, whatever, and you know the mouse is clear, and it's not going to give you a double reading or a false reading. It's not going to read a side marker when it's a crossover. On its first run, Wiz runs round a reasonable pace. You don't want it to go too slowly, because you might find that your speed run has a little bit of wheel slip or something like that. So you go as fast as you can, but safely on the first time, and you record the position of all of the markers and the start-stop markers. My robot only has 2 speeds, slow and fast. Slow is for the survey and for anything that isn't a straight, and then fast is for any straight over ½ a meter long. It doesn't read any of the sensors on the second and third run. Once it's mapped the course, it runs completely off that data. So imagine the mouse is coming round in this direction. It's going around a tight bend, so it's slow. In the program, in the process, after it's finished its survey run, I add 100 millimeters, effectively 100 millimeters worth of odometry reading onto that sensor, onto that marker there, and on the one at the end of the straight, I subtract 200 millimeters. This is to make sure that the mouse is fully clear of the curve before it starts speeding up, and to slow down in plenty of time to take the next tight curve. So you record the odometry readings when you do the survey as the average of both left and right encoders. You could also record it as the sum of those 2 encoders. It's the same thing. Now, when you read the markers, it's the same issue as when you're reading crossovers. You've got to make sure that you don't double detect and you don't miss the markers. My pick, there's the actual pick, Pete. It's the 18F25K22, if you're thinking of using one. It's got the leading edge of the marker is detected, because these are just connected to a digital input, and a flag is set in the program which says stop reading for any more. You've got one. Take note of the encoder readings. And then it does this, add on a certain amount, 20 millimeters should be okay, and that ensures that you've cleared the previous marker, and even if they're that close together, I think this is about the closest you can get them on a fair course, that shows that you clear the previous marker before the next one is encountered. And I think that is the worst case, where you've got about 60 degrees of curve. Nobody in their right mind would have less than 60 degrees, surely.
Each section has to be 75 millimeters along the centre of the thing.
Okay, so nearly done now. Sensor calibration and runaway prevention. Before the start of the run, Wiz does a pirouette and looks at the line and takes the maximum and minimum readings for each sensor, and it uses those to normalise the readings when you're actually surveying the course. I've got mine corrected to between 0 and 500, so 0 on the black, 500 on the white. And then this business of adding the sensor values together, whereas when you add them together and they're a high sum, that means it's a crossover. When you add them together and it's a low sum, it's the black, you've run off the course and you're going out of control. So in which case it stops immediately. So that means that you never see it whizzing across the floor, crashing into a wall, because as soon as it loses the line, it stops. Batteries, they're very important. I advise you all have one. And the batteries that I've used, I've tried the Zinter, I think you say, 9 volt, and I've tried the Liter 9 volt, and they're not the same. They both say 9 volts on them, but the Liter one comes out at 8.4 volts, and the Zinter one comes out at 9.5 volts. This is freshly charged, unloaded. So you'd expect there to be a difference if you use the Liter, and there is. Wiz takes about a second longer to complete the 2023 course than it does with the Zinter. If I put that on, I might get a time of about 8.5 seconds, and on this one, about 7.5 seconds. So it does pay to take care of what battery you choose. Future developments. I think that Duncan came up with the idea of running a racing line. And if you, as I don't calculate radius and curvature from my server data, but I could, and in which case I might be able to take a racing line and take curves wider so that although you're going slightly further, you can go faster. There might be a net gain there. The problem is with my method of recording the position of the side markers, I'd have to make some corrections to those if I was running wider. So it's not a simple change to make, but it might be worth doing if everything else has been done. You can reduce the weight. My homebrew PCBs are pretty heavy. A professionally made one could be made a lot thinner material, 0.8 millimeters, which would take a bit of weight off it. You could use individual lipos instead of a pre-made battery. So increasing the speed for larger curves is possible. I only have 2 speeds, slow and fast. There could be an intermediate couple of speeds, and I could work out what the radius is, and I could choose the speed according to the radius. I don't do that at the moment, just 2 speeds. And lower the centre of mass. I was talking to Duncan the other day about putting a lead weight underneath the centre of rotation, and he said, "Oh, I've already done that." So there's nothing new in in this world. But there's no other thing to say. So any questions? Yes.
I've got a point about your batteries. Right? With the motor drivers that you use, they work okay if the battery is current limited. And the Zinter ones have got an internal current limit at about 1 amp. And that could mean that you've effectively got torque control on there.
Yeah.
And you can't spin those wheels.
Yeah.
On the other one, they might have a different layer of current limit or no current limit, in which case you might be able to spin the wheels.
Yeah.
So that battery is actually an integral part of your motor control.
Yeah, there's a lot of interdependencies. You wouldn't believe it. Another hand, that's all? Yeah.
On the crossovers, if you get to a crossover just after a sharp bend, you have the possibility that as you come to it, you're going to be slightly offline.
Yes.
And you're still going to see one side before the other side.
Yeah.
And if it's the first time you see those side markers, you can think it's a side marker for a fraction of a second. Are you doing something to Get over
Do you
that
remember
problem.
that I said that I'd made a decision early on to put the side marker sensors on the axle line?
Right.
So the front sensors, which are the ones that detect the crossover, will detect it. If you set your threshold correctly, you can allow for a bit of an angle of the approach.
Oh, right. Okay. Yes.
And then the side marker sensors are going to be half a mouse behind that line. So you make sure that you've moved forward over half a mouse, and you then start detecting for side markers again.
Right. Okay.
So that's
Yeah.
For a crossover,
Yeah.
there is a guarantee.
There is, yes, 75 millimetres or something.
Yeah.
Wouldn't be true.
Not
Yes.
Not until the flip trays.
If you're not going straight onto a crossover, what stops the control algorithm initially seeing the line and moved over drastically?
yeah. I think if it was really, we're talking sort of odd degrees here and there.
Yeah.
If you're under full control and not going too fast for the mouse's capabilities, it should see a crossover pretty well perpendicular. So I think I can't answer it in sort of mathematics. I'd say I've never noticed it being a problem, but you have to have a certain distance before the crossover of a straight. And I suppose my control is keeping the mouse right on the line. Therefore, all the sensors are seeing it at the same time. But if it ever runs out of control, I'll bear your point in mind.
Well, maybe it's only, if you're jumping at meters per second, well, you might only have a millisecond or two or three. Maybe it's probably not fast enough to respond to that signal anyway.
Yeah, that seems to be, the meter a second seems to be a good a target or achievement. If you can get a mouse to run at an average of a meter per second round a half-size maze, you're doing pretty good. Yeah. Okay,
I just wanted to raise the point about the wide sensors. If you've got a wide sensor and you're using a PD controller with no eye turn, then you can set your D and so on so that it actually tracks on the outside of the curves. Right, it's on a straight line, it's obviously going to be in the middle.
Yeah.
But when you're off to one side,
Oh, right. Yeah.
you've got to have an error to make it turn.
Yeah.
And that error corresponds to a distance offset towards the outside of the curve.
Yeah.
That allows you to go faster.
Yeah.
Screws you up on the points of inflection, but
Yeah.
so it sort of gives you a bit of a racing line accidentally.
Yeah.
okay, so this is something that I wanted to do last year, but we ran out of time. It's a Visual Basic maze editor, solver, you name it. So what I've got is the ability to import a text maze by pressing that button using the Windows dialog. That appears there, and then you can edit it in this panel by selecting use imported maze, setup maze, search, and you've got these commands to move the mouse and rotate the mouse, and you can toggle walls to the left, ahead, or right of the mouse. So if you're designing a maze, a text maze, instead of having to do it the hard way, you can actually take an existing one and make some modifications. You might not find it terribly useful, and you might not want to have it written in BASIC, but it might give you an idea of what can be done. So I'll import a maze. I'll import a random maze, and I'll do -20 maze A, open. And then I'll set up maze, a blank maze, and then I'll press search. And you can see that the mouse is searching the maze for the goal. I've set the goal at 7-7. And when it finds the goal, it reports that it solved it in 58 moves and found 33% of the walls. And then it goes back to the start using usually a different route. This is recording the path here. So it's going back to the start, and it's now found in 76 moves and 60% of the walls. So if I search again, it should pretty well find the best route now. So it's found quite a lot of walls, and it should know what the best route is. Probably not this time. It'll probably be quite close, but not the shortest route. That's 56 moves, 69% of the walls found. And on the way back, it's probably going to find the shortest route this time. By shortest, I mean the number of cells. I don't mean taking into account diagonals and things like that. So this time we're down to 50. Okay, so if I ran that again, it should just say 50 again. And if I want to replay the last search, I can press show path. And what it does, it just saves a trail of the mouse. It just replays the data off here. And it's not solving, it's just replaying. So it won't find the shortest route because it found that on the way back last time. So this will be the 56 move route it's showing. So if I'd searched one more time, it would have shown the 50 route. So there's the basic software. You can save that maze as a text file there. So basically, if all you want it for is to open up an existing maze and change it and then resave it, it can do that. You can have a blank maze and add your own walls and save it, and then you can import existing mazes and you can solve them and you can record the route. Any questions? No. Good. Really, that's back on schedule, I'd say.
Well, thank you very much for that. The minute I get my PC upgraded, I'm going to install it. But it's very nice. And I would recommend to all of you that you should really have some kind of simulation for your maze.